Dear mentors, this is the second video in the series, The 8 Standards of Mathematical Practice. Let's remember that the 8 standards are good visible ways in which excellence comes when you do math in the classroom. So excellence means doing these 8 standards and vice versa. If you do these 8 standards, you'll find excellence in teaching and learning of mathematics. In the first video, we already covered the first 4 standards: make sense of problems and persevere in solving them, reason abstractly and quantitatively, construct viable arguments and critique the reasoning of others, and model with mathematics. In this video, we'll consider the last 4. 5. So use appropriate tools strategically. So this is like a carpenter or somebody that likes using tools and knows all the tools, has a lot of experience of what works and what doesn't really work, knows all the limitations, etc., etc. So in the sense of math, this means using tools to do math, deciding which are helpful and recognize their limitations, using tools with flexibility. You can adapt them sometimes for specific situations or tasks. Using the tools in free goal activities. You don't necessarily have to use them for solving a specific task, but you can just use them to explore and make sense of mathematical ideas, gain intuition and enhance comprehension of mathematical concepts. What are these tools? What are we talking about? So there's several tools. The most prominent are the following. Of course, paper for writing formulas or just generating visual models such as tables, pictures, bar models, etc. So paper and pencil. Geometrical tools such as rulers, protractors, compasses, things that help you do geometry with precision. Concrete manipulatives that model mathematical ideas such as abacuses or card and board games. You could also have fraction disks, any tool that can help you gain insight with a concept. Databases or mathematical textbooks or problems that you just found in books or on the internet electronically. Technological tools such as calculators, spreadsheets, computer algebra systems that allow you to graph or to make sense of formulas and equations. Statistics and data management software. Game simulators, which are picking up in education, which is very good news. Geometry software, among many others. It's important to understand that it's not just the tool in itself that has the mathematical value, but it's what is the purpose of the tool and what is its correct or incorrect use. So that also has to do with this standard. It's not just knowing what the tools are, but why? Why do we use them like that? 6th standard deals with attending to precision. So think of a surgeon or a dentist or some job that requires doing things carefully with precision. So in the context of mathematics, it means know and use definitions explicitly, like you know explicitly that you're using them when reasoning with others or working alone. Correctly use conventions, labeling, any tools or cues that help in your system, symbols, unit of measurements. Estimate and approximate values and data. So have the flexibility and be able to adapt accurately to your context. And finally, develop the skill of examining claims in detail. So a claim is some statement that may be true or false. And in this standard, attend to precision, you want to be able to actually break it down into more parts or relate it to previous claims. So you want to be able to be very precise, use a lot of rigor. Okay, number 7, standard 7, look for and make use of structure. So here you want to think of a detective that sorts clues, looks for new ones, has a lot of experience in navigating and organizing all these bits of information. So in the context of math, it would be the following. recognize numeric facts in specific examples that would be generalized later. So for example, the commutativity or associative law in mathematics, explore these facts in examples when just doing arithmetic, being able to find these patterns and to anticipate what's coming next. Learn about typical elements in visual diagrams that they can be incorporated in other diagrams. So this is the ability to transferring. When I learn something, sometimes some representations have a lot of details. What if my new representation is not that accurate or is not that full of detail? The ability to transfer these skills of filling out details, it's important and it's visible in this standard. Also look at representations at different levels of detail, and also being able to decide in which problems, which level of detail it's convenient. I think as a detective, sometimes the detective says, I don't really need these details for this case. Or maybe it's like we are really going to need everything, all the information. So it's about deciding these type of things. And finally, interpret algebraic expressions or a diagram in different ways, which means sometimes when you're dealing with expressions, you could view these expressions as a sum, sometimes as a product, sometimes as different things. And this is useful because you're using tools from before. So it's important how you view things in mathematics, because then you're going to make choices, and those choices depend on what's your perception. Detectives are good at that, of course, so that's also important in this standard. The last standard is look for and express regularity in repeated reasoning. So think of an orchestra conductor that can see the big picture, and he can start to pick up some patterns of this orchestra and streamline things, make them more efficient, make choices so that everything flows more smoothly. So this standard is probably the reason why it's the last one. This means attaining these standards means some great deal of mathematical maturity. So what is it about it in math? Discovering shortcuts when repeatedly applying the same steps in a process. So for example, you could say, we're going to apply the same process as we did here, because it's really the same. Finding general formulas or patterns from concrete cases. Contrasting discoveries of specific parts of a plan with its big picture to see if the details really align with the idea of the plan. So there's also some feedback issues here that this orchestra conductor has to be aware of, right? He's not just in that system and he believes in it, but sometimes as he detects some discrepancies maybe with the real world or with other hypotheses, he has to adjust and he has to always check for that. Now, I have described all these standards in isolation, but they don't really work in isolation. As you can see, many of the skills are actually overlapping in different standards. And so you could view these standards as different light angles or different perspectives that are characterizing excellence in teaching and learning. And so they should naturally overlap. They're just indicators, they're just signals that you're doing things right in math. But it shouldn't be viewed as a checklist because they actually overlap a lot. I would like to finish this video by assigning some reflection questions so that you could think with your peers. So here are the questions. Why do we need the standards? Why is it important to be aware of them? Second, in which order should they be promoted? Should I go just in order as they are stated, or should I start in the middle? What's the best order, if any order at all? Are there some standards more important than others? Or do they all have the same value? And here I should give you a small hint. It sometimes may depend on the maturity. And as you saw in these videos, actually the standards are telling a story. They're telling some development that may not go in order, but you start seeing some connections that give you hints on what are more important, which standards should I maybe focus on first when I don't have this mathematical maturity, and which others are more like, making things smoother and more rounded. And finally, the most important question now for teachers, how do you use them in teaching? How are you going to train your students, or how are you going to make them visible? Which routines, which procedures? Are you going to use them in the plan, in the curriculum plan? Are you going to put posters? Are you going to check for them one every lesson? And so there's many answers to these questions, but I will let you think about this. Thank you.